I thought it was important for us to look at some other examples of calculations involving osmotic pressure. So I'm just going to do two examples right here. Let me do this first before okay. So let me go back up here. All right, so this is the first example. Let me go to my full screen mode here and let me select my pen. Okay, so this question gives us a couple of pieces of information. It gives us the mass of the urea, it gives us the volume of the solution, and it gives us the temperature. And the question is asking for the osmotic pressure, all right? So the equation we're going to use is what we just saw. P is equal to mRT, and the question is simply asking for, actually that should be pi, not P. So pi is what the question is asking for. M is the molarity, R is the molar gas constant, T is the temperature. Now the question did not give us the molarity, but the question gave us the mass in grams, and it also gives us the formula, and it gives us the volume. So basically, what we need to do is find the number of moles of urea. So we take that and we multiply that by 1 mole over the molar mass of urea. Now I'm going to be a bit lazy here. I'm going to look up the molar mass of urea because I don't want to waste too much time. Mass of urea. And that is equal to 60.06 grams per mole. So let me go back to this slide right here. So I'm going to put here Oops. So I'm going to put here 60.06 grams of urea down here. And then I'm going to multiply that by R, which, as I said before, is 0.0821 liters atmospheres over mole Kelvin, multiplied by the temperature, which is expressed in degrees Celsius, but we need it to be converted to Kelvin, so we have to add 273 to that, and that becomes down here to be equal to 293 Kelvin. And that's it. There's no divided by anything. So the gram units will cancel out here and here. The moles will cancel out here and here. The Kelvin will cancel out here and here. And that's basically it. Now there's something missing. I'm not sure what it is. I forgot. I should have divided here by the volume. So the volume is in liters, should be, but they gave you milliliters. So that will be equal to 0.145 liters. So the liters unit will cancel out here and here. So this underscores the importance of including units, because as you can see, I made the mistake of ignoring the volume here, and I realized that the liters should have canceled out. So basically that was the missing piece. If I did not include the units, then more than likely I would have missed out on including this, and therefore the answer is wrong. So this is the reason why I am very anal about basically including all units in your calculation. And this is what I expect from you guys. Okay, so let me go ahead and put the numbers in my calculator. Divide by 60.06 times 0.0821 times 293, and divide that by 0.145. And according to my calculation, when rounded off to 3 sig figs, this becomes equal to 5.58 atmospheres. And that would be the osmotic pressure of that solution. All right. Okay, I'm going to stop here. The next video will be another example of a calculation involving osmotic pressure.